I'm on it. I'm on it. Oh, I better turn that on. Zero, zero, 5, 0. Hold on, didn't take. All right, so now once you get the A's for this one, we just started this first problem. Those who just came in. You want to find the B's, which are the constants, all the factors of the constant. Now this one has a few, 1, 2, 4, 5, 10, and then 20. Now the possible roots are B over N. Okay, every factor of B divided by every factor of N. So the possible roots. Now you take all those divided by 1, and we've talked about this before, you get all the constants. And I always just write those down first. So I'm going to get every constant I can. So 1, 2, 4, 5, 10, and 20. All right, now divide them by 2. You do not need to list anything twice. And so always reduce just to save yourself some time. 1 divided by 2 is a half. 2 divided by 2 is 1. We already have that. 4 divided by 2 is 2. So we are taking, I should make sure I explain this, all of these, dividing it by 2 right now. 5 divided by 2, we don't have that one. That's 5 halves. 10 divided by 2 is 5, and 20 divided by 2 is 10. So we're only going to get 2 new ones out of divided by 2. Now, what's the next one? Divide by 3. Unfortunately, okay, I do get a few new ones there because I think they're all new. 1/3, 2/3, 4/3, 5/3. What do we got left? 10/3 and 20/3. And after you divide everything by 3, divide everything by 6. That one doesn't come out as bad. Okay, not everything's going to be unique. So 1 divided by 6 is 1/6. 2 divided by 6 is 1/3. We got that. 4 divided by 6 is 2/3. We got that. 5 divided by 6 is 5/6. And I think that's the last one because 10 over 6 is 5/3 and 20 over 6 is 20/3 or 10/3. All right, so that's, now what do I do after that? Oh, Joshua, welcome.
Hello.
You're done. All you do is list them. Okay, so just make sure you follow directions on that one. All right. This is the first one we've done, Josh, but you haven't missed much. Okay. All right, take a look at this one. All right, go ahead and copy that down and think about what you do. Go ahead and pull your calculator out if you don't have it. You'll want it. Aaron, how's it going? Good? All right, thanks. You are allowed to use your calculator on the whole test, so that means, what should you do right now? Graph it. Graph it and see where it hits the x-axis. Okay. Okay, all right. Now, theoretically, I just really need to find all the zeros, kind of give you a little bit of a hint there where it says real and complex. Okay, doesn't always mean that's the case, but how many times does it hit the x-axis? It hits it twice, right? How many total answers should we find though, because it's fourth degree? We need to have, in the end, counting multiplicity, counting complex, we need to have 4. So this is a case there where we see where it hits the x-axis and we use that, and then we use synthetic division. So I believe it hits at -3 and 3. So I'm gonna start at -3 and do synthetic division. And double check, make sure you're not skipping a term. If you're skipping a term, you gotta put in a 0. So I got 1, -2, -4, 18, -45. And go through here. And it should equal 0. It has to equal 0 as long as you don't make a mistake, and as long as you typed it in your calculator right, and then hit the 0 there, it's got to equal 0. And if we add vertically, we get -5 times -3 is 15. -4 plus 15 is 11. -33. And what is that? -15 times -3 is +45. 0. Now that means you don't necessarily have to write this, but that if x minus 3 is a root, that means x plus 3 is a factor, and it means x plus 3 times x cubed minus 5x squared plus 11x minus 15. That product will equal the original. Well, now you always want to use what we call the depressed polynomial, and now you take your other root, which we said was +3. And that goes into 1. That goes 1, -5, 11, -15. That's a 0. 3, -2, -6, 5, 15. 0. So now I'm at x minus 3, or excuse me, x plus 3 was the original. That gives me the factor x minus 3, and then this gives me x squared minus 2x plus 5. All right, at this point, you look on your graph and hit the 2 zeros. You're going to have to use quadratic root formula to find your others. Oh, well. Finishing the AP line one. Oh, yeah. Well, good to have you. Thank you. And you should expect to get back an I in your answer because it did not hit the x-axis anywhere else, at least, from what we could see. So I got x equals -b plus or minus square root of b squared minus 4ac all over 2a. A is 1. B is -2. C is 5. I'm going to substitute in. Opposite of -2 is 2. -2 squared minus 4 times 1 times 5. And then 2 times 1 will give me 2. All right, welcome. Thank you. Is Peyton still there? Yeah, all right, see the last one. All right, good. And then what do I get here? I get 2 plus or minus, what do we get there? Square root of -16 over 2. 2 plus or minus 4i over 2. And so now in the end, I get 1 plus or minus 2i. Don't forget to list your roots, your zeros. -3, 3, 1 plus 2i and 1 minus 2i. Yes, you can write that as plus or minus 2i. That's fine. But you got to have those 4 roots. Okay, we got -3, +3, 1 plus or minus 2i. And hold on here. Those of you just missed. All right, the first one we just looked at said just list all the rational roots, the possible rational roots. So all you have to do is do the A and the B and the possible roots of the B over A. Okay, so you read the directions and just say list them. That's all you have to do.
Are you recording this class period?
I am. Thank you. I am. Hey. So the first one I said just said list all the possible rational roots. You didn't have to find them. I don't even know what the roots are or if there are any. They might all be complex for all I know. Well, one of them has to be. And then for the second one, it says find all the zeros. You are allowed to use your calculator on the whole thing. So you would graph it, find out where it hits the x-axis, and kind of go from there. So in this case here, y equals, what is that, x to the 4th minus 2x cubed minus 4x squared. Oops, what did I do wrong? Oh, I didn't hit the minus. Minus 4x squared, and then plus 18x minus 45, zoom 6. Now there could be some stuff going down below, but you just see it's -3 and 3. So you just use those with synthetic division. Okay. Oops. All right, some composition of functions. So get your 2 base functions down. Think about what would be f of g of -3, and then we'll take a look at g of f of x, just in general. Okay, f of g of -3, and then g of f of x. All right. I mean, is this not anybody's sweatshirt? This is not, nobody's claimed it. Now for f of g of -3, that means you plug in -3 into the g function first. And that's going to be 2 times -3 squared plus 7. And -3 squared is 9. 2 times 9 is 18 plus 7 is 25. From there, plug that into the f function. And you get 3 times 25 minus 5 equals 70. So in the end, f of g of -3 equals 7. All right, what's g of f of x look like? So g of f of x means you take the f function, the whole thing, and you plug it in for every x in the other side or in the other function. In this case, there's only the one x. If there's more than one x, you'd have to go into each one. So g of f of x, 2 parentheses, 3x minus 5 quantity squared plus 7. All right, go ahead and make sure you FOIL that. Distribute the 2, combine like terms. You do not have to factor, do not try to solve it. Just simplify it. Okay, just simplify it. And when I FOIL those, let's see what I get. I get 9x squared. I get negative 15x. I'll get another negative 15x. I'm just going to make that minus 30x. Negative 5 times negative 5 is plus 25 plus 7. Distribute the 2. 18x squared minus 60x plus 50 plus 7. And let's see here, 18x squared minus 60x plus 57. There is a GCF of 3. You don't have to factor that out. Just leave that. And definitely don't solve it. Okay, 18x squared minus 60x plus 57. All right, so that's composition of function. Ooh, domain. All right, copy that down. Think you remember how to do that. All right, Josh, remember what to do? Or what we need to worry about? What's that?
The radical has to be greater than or equal to 0.
Okay, good.
No, there can't be 0.
Two key things we got to worry about here. Radical has to be greater than or equal to 0. Yeah, it can equal 0 in the numerator. That's fine. So 2x minus 5 has to be greater than or equal to 0. And the denominator cannot equal 0. So x minus 8, where it equals 0 is going to be x equals 8. Throw that out. Okay, simplify this to get x by itself. I get 2x is greater than or equal to 5. Divide by 2. I get x is greater than or equal to 5 halves. All right, think what your final answer is going to be. You got to write an interval notation. Okay, what's your final answer going to be? So it's got to be bigger than 5 halves. So I'm going to start at 5 halves, but we can't include 8. So it's going to go to 8, 5 halves to 8, union 8 to infinity. Okay, so 5 halves to 8, not including 8, union 8 to infinity. Okay, for that one. All right, let's take a look at one more here. All right, I'm going to give you the graph. You give me the equation. All right, think about what that would look like. You can keep the equation in factored form. Just so it helps you out, it hits at -2, it hits at 2, and it hits at 4. One thing always consider, we'll have a positive or negative leading coefficient. Okay, and that's just, if it, and now in this case, it has to have a what? A negative leading coefficient, since it opens down. And so just put a negative in front. Okay, just put a negative in front of the whole thing. If it hits at x minus 2, or if it hits at, -2, that means you have to have a factor of x plus 2. But since it bounces, remember that has to have a multiplicity of 2, and we're always going to do the smallest multiplicity. Okay, technically it could be 2, 4, 6, but just always do the smallest, unless told otherwise. Now it hits at 2, so it means it has a factor of x minus 2. Okay, it goes straight through, so it's first degree, and then it hits at 4, so you got a factor of x minus 4. All right, that would be it. You got to make sure to check a positive or negative leading term. Check your multiplicity of your roots. Make sure the degrees match up. This will be second, third, fourth degree. That matches up since they both go down for that one. All right, now last thing here is just kind of the makeup. I kind of went through here for a little bit. 1 through 14 will be day 1. It is all chapters 1 and 2 except on a multiple choice, there's just a couple from, chapter 4, like the log, simplifying and expanding. Okay? And then really 15 through 25, it's really, 3, 4, and 10, and then there is a couple problems from chapter 2. Okay, they all didn't fit on the first one. Chapter 3 is just what we just did, like the multiplicity of the roots, finding the zeros. Chapter 4 is logs, which wasn't that long ago, and then chapter 10 was conics, which we just had. So 25 is true false, so that could be anything. Okay, that could be anything. All right, go ahead and work through the exam review. I mean, I at least try to get through 9 through, what do we do, 9 through 18. I try to do that.
Stick it up there.
Those of you who came in late, I did post the exam review answer key, so as you're going through here, you can check it, but make sure you know how to do them all. And then it does need to be uploaded before Thursday. Okay, and it will count.
What do you want to?
Yeah.
I did the exam today.
I wish I could let you, but I can't.
Yeah,